This is Kenji Fuji speaking. This time I would like to make a presentation entitled Observation of Damage to Uto City Hall Suffered in 2016 Kumamoto Earthquake. So let us start from introduction. On 14th April 2016, a large earthquake hit Kumamoto Prefecture, Japan. 2 days later, another large earthquake occurred, mainly affecting Kumamoto and Oita Prefecture. The maximum seismic intensity defined by Japan Meteorological Agency is 7 at Mashiki Town, which is the most severe intensity. The seismic intensity at Uto City is 5.5 in earthquake occurred in 14th, while it is 6.2 in earthquake occurred in the 16th. Uto City Hall, shown in this photo, was severely damaged during earthquakes occurred in 16th of April. I had visited Uto City about 2 weeks later and made damage observation from outside. At that time, I was really curious about what happened inside this story, but of course it is too dangerous to go inside. 2 months later, I had a chance to carry out the damage surveillance mission inside this building using a mobile robot with second to fourscore Earthers. So I would like to show you about the damage to the main building of Uto City Hall. I would like to explain the basic information of this building and also building damage from external observation. Uto City Hall is a 5-story reinforced concrete building. The construction of the main building was completed in May 1965. The damage of other buildings were only minor or none. Because the access to the area inside the red dotted line was restricted, I had made observation from outside. This photo is the main building from the south. And this is a photo from the west. And this is from the north. So I would like to explain the damage to each elevation. Here shows the south elevation. The first is a photo of a 5th-story column. Large flexural cracks are observed at the top of the 5th-story column, and the aluminum window frames were deformed vertically. And next is a photo of a 4th-story column. Falling of the cover concrete at plus-shaped beam column joint were observed. Next shows the west elevation. The first is a photo of a west side corner column on the 5th story. Large flexural crack at corner are observed. In addition, there were large vertical openings and cracks observed near T-shaped beam column joint. Next is a photo of the 4th and 5th stories. The 4th stories had partially collapsed, and beams on the 5th floor were inclined. And the last is the north elevation. The first is a photo of a column on the 5th story. Some large flexural cracks were observed at the top of the corner column, and large diagonal cracks were observed at the end of roof floor beams. Next is a photo of the 5th floor beam. There were large diagonal cracks at the end. From external observation, it may be concluded that the main damage to this building was limited to the third, fourth, and fifth stories on the south and west elevations. Next, I would like to explain about the surveillance of the main building by mobile rescue robot. Here shows the mobile robot Sakura Ichigo. The word Sakura is a Japanese word means cherry. This robot is developed by Furo, mainly by the second to fourth co-authors. This is the upgraded version of Queens, which surveyed inside the Fukushima Daiichi nuclear power plant. The surveillance time by the robot was approximately 100 minutes, with the surveillance robot traveling approximately 250 meters. Here shows the video of surveillance mission. So, I would like to show you the surveillance mission results. What I'm showing to you is the inside of the first floor. As far as observed by the robot, no damage is noticeable. On column A2B2, no cracks were visible, so the damage class classified according to the guidelines for post-earthquake damage evaluation and rehabilitation is less than 2. Next, I would like to show you the inside of the fourth floor, where the most structural damage seen from the outside. What I'm showing you is the photo at the border between the stair block and the office block. In this place, the floor slab is severely damaged, and the finishing materials of the ceiling have fallen off. This is a photo of the column A2B2 inside the office. This column is actually collapsed. At the top of the column, the buckling of longitudinal bars and large vertical deformation is visible. The measured height of the ceiling around this column is about 1,500 millimeters, whereas the ceiling height of the fourth floor, according to original structural design, is 2,600 millimeters. Therefore, the actual deformation of column A2B2 is approximately 1,100 millimeters. The damage class of this column is 5, the most severe class. So let me go up to the 5th floor. What I'm showing to you is a photo at the shear wall in frame Y5. Large diagonal cracks and exposed of reinforcing bars are visible around the door. The damage class of this shear wall is 5. So, I would like to move to the discussions and conclusions. In this presentation, the damage to the main building of Uto City Hall is discussed. Based on the external observation, it is found that the third, fourth, and fifth stories of the south and west elevations were severely damaged, whereas in the northeast stair block, there is only limited structural damage. Next, the robot surveillance mission inside this building was carried out. Based on the results, it may be concluded that most of the structural damage to the main building of Uto City Hall was concentrated in the upper stories. Some of columns on the fourth story lost actual strength necessary to sustain vertical loads. This is the end of the presentation. Thank you very much.